Okay, so models. That means we're going to take data and we're going to build equations from that data. And most of it's going to be done in the calculator. So you have exponential data. So what all these dots represent is data that's been collected. They're going to give you a set of ordered pairs, basically, and you're going to put that into your calculator, and you're going to look at the scatter diagram to decide what kind of data you have. Exponential growth going up and to the right, exponential decay going down and to the right. Notice how these go into the x's being negative, but on the logarithmic, it's almost kind of the same shape, but it never goes into the negative x values. Okay, logarithmic down, logarithmic up, but it never goes across the y-axis over into the negative x's. That's a big thing difference in those because the scatter diagrams look very similar. Here you got this exponential decay and the logarithmic there. That's almost the same shape. The difference is does it cross over into the negatives or not? If it does, then you know it's got a exponential decay. If it doesn't, then it's probably logarithmic. Okay. A lot of the problems are going to tell you what kind of regression to do. It's going to say find the logarithmic function or find the exponential function out of that. Okay. So you got logarithmic, you got exponential, and then you got logistic. Remember the logistic makes that kind of S looking shape. Every one of the graphs that you looked at on homework yesterday had that S kind of shape. You're going to see that with logistic out of that. So recognizing that scatter diagram is a key thing. So let's look at the first example there with a set of data. It says Mariah has deposited $20,000 in a well-diversified mutual fund 6 years ago. The data in the table represents the value of the account beginning at the beginning of each of those years for the last 7 years. Okay, so we have data here. I'm going to go to my calculator and I'm going to put that data in to the lists. Okay, so calculator time. So I'm gonna clear out anything that I've got graphed. I'm gonna clear. Okay, and I'm gonna hit the stat button, and under edit, I'm gonna hit enter. Look at your list. Do you have L1 and L2 there? I don't care if you got L3, L4, and L5. We don't need those. You just need L1 and L2. Is anybody's not have an L1 and an L2 there? Doesn't matter if you have data in there or not. Is there anybody's that doesn't have L1 or L2? So hit the stat button and enter, and that should get you there. Stat is right there beside the circle, right there. And then just hit enter to go to edit. Okay, now to clear out a list, if you got stuff in there, you can press the up arrow until L1 or L2, whichever one you need to clear, is highlighted, and then hit clear and enter, and it'll dump that whole list out. So you don't have to delete each one individually. Okay. Now on L1, I'm gonna put my years. So 0, 1, 2, 3, 4, 5, 6, 7. Whoop, don't have a 7. Sorry, went too far. So just type the number, hit enter. Type the number, hit enter. It moves down. In L2, I'm going to put the Y value or the count value that's right beside it. Got to make sure you pair them up. Don't swap the order there accidentally or mistype. So putting that data in there, 21, 516, 23, 355, 24, 885, 27, 484, 30, 053, 32, 622. Make sure you got your data in there. Make sure you didn't transpose a number or something like that, because that changes it to a different set of data if you do. Okay, all right, so underneath there, it tells us Use the graphing utility to draw a scatter diagram with year as the independent variable. That means the year is X. That's what that means. Okay? So to get your calculator to draw a scatter plot, you're going to hit second y equals. I'm going to use plot 1. I'm going to hit enter right there. And right now my plot 1 is turned off. I want to turn it on. And then I'm going to go down to type, and I'm going to hit enter on the very first type. That's a scatter diagram. Your calculator does lots of things. It'll do a scatter diagram, it'll do a line plot, it'll do a histogram, it'll do box and whisker plots, and then this is a step function is what that is. But only one we care about today is the scatter plot, so it's that first option. If you got the color version, you're going to get to choose what color you want your box to be. It doesn't really matter. L1 should be X list, L2 should be Y list. That should be already in there. You shouldn't have to change that. Okay. Then on the mark, you pick whatever you want to there. Square plus dot, big dot, little dot. I usually leave it on the square because it doesn't really matter. Okay. Now I'm going to hit graph, but you're probably not going to see much. Now here's how you reset your window to fit that data. Hit zoom. And then down there at the bottom, it says on 9 is zoom stat. That will fit the window to the data that's in your calculator in the list 1 to list 2. Zoom 9 or zoom stat. We see this, not a lot of data here, so it's kind of tough to tell what kind it is. So we're going to hope that they tell us to what kind to build. They say using on B part there, it says use a graphing utility, build an exponential model. That's nice because that's going to be exponential growth because it's going up and to the right. They told me exponential, so I know that that's what it should be. So I'm going to go stat. I'm going to press the right arrow key to go to calc. And then I want to do exponential regression. So I'm going to scroll down until I see EXP REG. There it is. EXP REG. That's exponential regression. I'm going to hit enter. If you've got the 84, it's going to ask you where's your X list, where's your Y list, and a frequency list. If you got the 83, then it automatically sets those as L1 and L2. You don't have to do anything. Okay, frequency list should be blank. I'm going to leave the store regression equation blank and just go down to calculate and hit enter. So just hit enter there on the calculate. If you got the 83, just hit enter. And it should build us a exponential, but it's not quite the form they asked for in C part. So A is 19,820. We'll go near cent here. So 43. So my equation for B part is A of T equals 19,820.43 times, and then I've got 1.085 or 0.086. If I go 36, yeah, let's do 0.86. 1.086 to the T power. Now, that is an exponential growth problem. On C part, they asked us to express that as A sub 0 times e to the kt. So I've got to work this out a little bit to figure out what this e to the kt part is. Okay. So what I'm going to do is I'm going to set the e to the k equals 1.086. Okay. So the t is the variable no matter what. I want to turn this into an e to a power. So I'm going to set it equal to e to the k. So that's what I've got to do to change this into the form they want. How do I solve that for k? Yeah, take the natural log of both sides. So the e cancels out, sorry. And then k is equal to whatever the natural log of that is. So I'm going to find the natural log of 1.086. And I'm going to go 3 sig figs here. So that's 0.0825. Okay. So on C part, my equation is going to be that 19,820.43 e to the 0.0825 t. So that's a little weird thing, but you're taking whatever the base of your exponential is and setting it equal to e to the k, and then taking the natural log of each side. And that's going to give you the exponent that should be up there with the t. So this is rewritten as a more like the PERT formula from financial things. Okay, it says graph exponential function found on part B or C on the scatter diagram. So I'm going to graph the one. I'm going to graph both of them just to show you that they are the same. So if I graph the first one, that was the 19,820.43 times 1.086. Is that right? 1.086 raised to the x. Then I'm going to graph that and show you that one. Look how close that fits the data. It's not perfect, but it's real good. Then I'm going to graph the one in C part. E to the 0.0825 x. Look how the red one covered up the blue one. They're the same equation, just in different forms. Okay? Same picture, though. It really fits the data pretty good. Not perfect, but wouldn't expect it. I rounded some, so it's not going to be exactly perfect. We're finding the regression equation is that equation of best fit. It gets the closest to all of the data points. Not necessarily going through all of them, but it gets the closest to all of them. Okay, so that's D part. We did the graph. E part, it says using one of those equations, predict the value of the account after 10 years. Okay, so I'm going to plug in 10 for T. I can do that with the graph too. I could hit trace. Now the thing you got to do with this, you got three things. I've got three things graphed. I've got the scatter plot, I've got the original equation, and then I've got the converted one that has the E in it. Okay. When I hit trace, it starts on the plot, which is not what I need to check with. I want to press the down arrow to swap to one of those equations. I'm going to swap to that E one just because that's the one I wrote out on my paper. And I'm gonna use that one to trace 10. So you got to make sure. And here's an error that I got. It says it's invalid because my graph, the window doesn't go to 10. If I hit the window there, I'm gonna hit window. Look at my X max. My X max was 6.6 when I did that Zoom 9. So when I did that Zoom 9, it gave me the picture, but it didn't get it far enough for me to work the problem. So I'm going to set my X max to like 12. I still see the scatter plot. I still see the graphs. But what it's going to allow me to do is trace to 10. So I'm going to hit trace, down, down. Now type the 10. So after 10 years, this account's going to have $45,227.86. $45,227.86. That's pretty good. Remember, we put 20,000 in and then left it, and in 10 years we've more than doubled our money. That's pretty good. Now, interpret the value of K in part C. So that K value I found, that right there is a growth rate. What percent am I growing by? 8.25%. So that's what the interpretation is. We are growing by 8.25% per year, which is really good. If you put money into a savings account up here in town, you're growing by about 0.1%, which is nothing. Well, it's not a bank; it's a mutual fund, and what a mutual fund is they take your money and they go play it on the stock market. They guarantee you a little bit back. They're making more than that when they invest your money. They're making bigger money than that, but they're giving you a part of what they made, and it ends up being like 8%. Some accounts are more aggressive, and if things are going well with the stock market, you could make like 12, 13%. But if things go bad, you might only make 1 or 2%, depending. And what they'll do is they'll have a minimum amount that they offer as far as interest goes. They'll guarantee you a certain amount, but if it's better than that, they'll give you the better rate. Okay? They don't give you all the money; they keep plenty for themselves. No question about that. But a mutual fund is a diversified. It says a well-diversified mutual fund. That means they took part of that 20,000 and some of it put it into maybe Amazon, some into Walmart or something else, and they played the stock market with your money instead of their money. And they said, okay, we're going to guarantee you 5%, but if we make more than that, we'll give you this much of the more than that we make. They're probably making 12, 13%, and they're giving you 8.25%, which is not bad. 8.25% is pretty good, especially considered in 10 years you double your money. Okay, you go easy. All right, so scatter plot, we built an exponential function with that one and worked some stuff out. Let's go to the meteorology problem, and we're going to build a logarithmic function with this data. So here we have Jody, who is a meteorologist, and she's interested in finding a function that explains the relationship between the height of a weather balloon and the atmospheric pressure on that balloon. She collects this data. She has the atmospheric pressure. She has the height. Okay. So we're going to put that data into our calculator. So I'm going to go to my calculator. I'm going to press Stat. I'm going to go to Edit. I want to clear those lists out. Make sure you got L1 and L2. I'm going to go to L1. I'm going to press up until L1 is highlighted, and then I'm going to hit Clear and Enter. That'll empty that list. I'm going to do the same thing on L2. I'm going to move over till I get L1 highlighted, hit Clear and Enter. So remember, to get to Stat, you're hitting Stat and Enter to get to that Edit, so you get your list to put your data in. Put the atmospheric pressure in the L1. Let's put that data in. Zero. All right. So as our height goes up, you see atmospheric pressure going down. The air gets thinner the higher you get. So that's why the pressure's less up there. All right. Then remember the height is in kilometers. The atmospheric pressure is in millimeters of mercury. All right, so using a graphing utility, draw a scatter diagram for the data with atmospheric pressure as your independent variable. Okay, that's why we put it in L1. Okay, so I'm going to hit second, y equals. Make sure everything is still set good. It should be, shouldn't have changed any. The only thing we're going to have to deal with is I graphed a couple of equations a while ago. I'm going to clear those out because this is a totally different situation. Now I'm going to hit graph, and if you'll notice, I don't see any of my data. I don't see the blocks. What did I forget to do? Zoom 9 for the stat. Now I see my data. Okay, so I've got my scatter plot happening there. I see it decaying down to the left or down to the right. B part says it's known that the relationship between atmospheric pressure and height follows a logarithmic model. So what we're going to do is use a graphing utility to build a logarithmic model from the data. So I'm going to hit stat, go over to calc, and I want logarithmic. So when I go down through here, there's a lot of different ones. Logarithmic is going to be this ln reg. That's the natural log. That's a logarithmic. Okay. LIN is linear. LN is logarithmic. So we're going to pick that one. So logarithmic, LN reg. Hit enter. Everything should be set correctly. You shouldn't have to do anything but go down there to calculate and hit enter. What it's going to give me is a logarithmic function that has an A value, which is a number, and then B times the natural log of this X. Okay. So we're going to have 47. I'm going to take a picture of it real quick. Hey. Perfect. Thank you. They told me if nobody came down here, I didn't have to come. So that's good news. All right. So let me. Yeah, that is a pro to that. That's good. Thank you. Saves me a little bit of time. All right. So we've got our information there that we want to write that equation there. So our equation is y equals 45 point, let's do 786, or let's see, our data had 3 decimal places in it, so I'm going to go 463 plus, and then we have negative 6.9025 natural log of x. So there's my function. It says draw the logarithmic function onto the scatter diagram, so that means graph that thing. So I'm going to go to the calculator, and I'm going to hit y equals, and I've got that 45 point, I forgot my numbers already, 7863 minus 6 point, I don't know the numbers there, 9025 natural log x. Hit graph. That should fit the data pretty closely. And it really does. Fits it really, really great. Okay. D part is where we actually use that. And it says, use the function found in part B to predict the height of the weather balloon if the atmospheric pressure is 560. So remember, atmospheric pressure was our X value. So all we're doing here is we're plugging in 560 for X. So I can either do that manually for D part. I can actually go and say y equals 45.7863 minus 6.9025 natural log of 560. I can actually type that in the calculator, work it out. Or I can go to my calculator's graph and hit trace, Press the down arrow to get onto my equation, and then type in 560 and see if it fits. Yeah, it does. 2.1077. And then that's in, the height is in kilometers. Less atmospheric pressure, higher up in the atmosphere. If you remember watching Top Gun Maverick in the beginning when he's flying the big the supersonic plane, and he has to get to Mach, was it not Mach 19 or something like you got to Mach 10. It was he was really high up, and the only way to do that is with the lower atmospheric pressure because it reduces the friction. All right, logistic function. So we've done an exponential, we've done a logarithmic. Here, let's do a logistic. So we got a lot of data here with this. So let's put that data into our calculator. Time is X, yeast biomass is Y. So get to putting that data into our calculator, and we'll build us a function there. So I'm going to clear out my equations. I'm just going to hit stat, edit, clear out my lists. 0, whoops, 0, 1, 2, 3, 4. Oh, 18 is where it stops. Whew, 9.6, 18.3, 29. All right, scatter plot that thing. Zoom 9. And really nice picture of logistic. You can tell that's logistic by looking at it, even if the problem didn't tell me that it's logistic. I can easily tell that that's logistic. It's got that S shape to it. Okay. And it says, use the graphic utility to draw a scatter diagram. We did that. Use it to build a logistic model. Okay, so we're going to build the logistic model. So we're going to hit stat, calc, find logistic. Okay, hit enter. Go down to calculate. It's going to give us all the numbers we need. Takes it a minute for logistic. It's a pretty big thing. You've got to find several numbers there. Well, mine's taking a minute. Yours might not take long. I don't know. All right, finally, I got my stuff. So C, remember, what's that number on the top of the big fraction for logistics? What's it called? The blank blank of the system. Carrying capacity out of that. So our function, our data had 1 decimal point. I'm going to go 2 decimal points in my rounding. So I'm just going one more than what I had. So my logistic model for B part, I got, just call this f of t equals 663.02 1 plus, and it was 70 something, 71.58 e to the negative 0.5455 x. So there's our logistic model. And then C part says graph that onto the stuff that you put in the scatter plot. So 663.02. I'm going to use the big fraction button. And 1 plus 71 point, can't remember the numbers, 58. Second natural log to get the e, negative 0.55 x. You should see that getting fairly close to all of those, if not going through all of those. A lot of data points there, so we can really get the more data points you have, the better your graph is going to fit. That's really the bottom line of that. So we see our logistic graph and our scatter plot matching up pretty close there. What is the predicted carrying capacity of that? So D part, the carrying capacity is the 663.02. That's in the biomass of that, so I'm going to assume it's in grams. If the function is found in part B, use it to predict the population of the culture in 19 hours. So I'm just plugging in 19. So on my calculator, I'm going to hit trace, press the down arrow to get onto my equation, and then type 19. 661.65. So using that calculator to help us plug that in. You could plug in 19 for X right here and work that, manually if you wanted to, but I definitely would use the calculator for that. Okay. All right. So very, very tedious thing here because you got to put all that data in. So every problem you're going to have to put in a new set of data for that stuff. But not hard work because the calculator is doing most of it for you. Okay. So on section 6.9, that starts on page 490. Number 1 through, there's not many of these problems. 1 through 10. Okay. So different data set on all 10 problems, but different scenarios. Make sure you read what type of model they want you to build out of that. Now, I did print this one. I'm going to give you the 6.9 quiz to take home with you this weekend. Bring it in Monday. Okay. That way you get the entire block on Monday to work on the review for that chapter 6 test. Okay. Getting the quiz for 6.9 as a take-home quiz. If I got time, you may get the 6.8 quiz as a take-home quiz too. Plenty of time over the weekend to get 5 questions on the quiz. I would do some of the practice first just to make sure I'm doing everything right, and then use that to help me do those 5 problems. So, and again, remember your crime scene stuff is due on Monday as well, and then we will test chapter 6 on Tuesday of next week, and then we will quickly go through chapter 12, which is matrix things, which is really easy. But we will go through that pretty quickly on Wednesday and Thursday, and that would give us Friday. The way things are looking, it doesn't look like we're going to have the days to be able to get that to have, because your finals on the 28th. It's set time and everything. So I definitely want to have time on the 27th for us to talk about practice final and all that stuff. So that only gives us like Wednesday, Thursday, and Friday to do chapter 12. So that may. Oh, good. Okay. Oh yeah, that was easy. Thank you, sir. Yep. So it's going to be a crunch next week, but remember we lost 2 weeks back in end of January, 1st of February. So for us to be able to get through everything is pretty good. But so that may affect how many quizzes or tests we have next week, because I definitely had rather you prepare for the final as far as that goes more than the test. So we'll figure out what we're going to do. I'll figure it out sometime over the weekend. 50. 50 multiple choice questions, pretty much covering everything. A couple of questions from every section. It's about what it is. But I've got practice finals and old ones that I've given that I'll give to y'all to prepare. And the final is always like the old ones. It's never off the wall different. It's pretty close to the same. Just numbers are different on every one of them. So, but 50 questions. You get 2 hours to do it. Doesn't usually take 2 hours, but you get 2 hours. They've got it scheduled in for that Tuesday as the English 1 and English 2 EOC is happening, so we'll be in here for an extended amount of time anyway. So that's how we usually schedule it in, so that you don't have to worry about interrupting in any of your other classes. Let's see. Yeah. So next week, the only day that we have testing happening is Wednesday, and it's not as long a day of testing as some of the other days. So we'll probably be in here first and second block on Wednesday, and then Monday, Tuesday, Thursday, and Friday are normal days.
May I have your attention, please? I need the following students to report to the cafeteria: Ashton Atkins, Landon Britt,